can at least smash this paper. They're saying that I just thank those people who tried to watch our predictions, and I think that the predictions, they really helped you to score a distinction. And if you have not got a distinction, still don't worry. We have now classes on Thunder Educ so that they can help you to obtain a distinction. They're saying that which one of the following groups of elements are classified as alkali earth metal? Alkali means that earth metals, these are group 2 elements. So if you don't know the group 2 elements, then you have to go to the periodic table and check. This is group 1, this is not group 7, group 2, yeah, group 2, group 2. So this is groups 8, this is group 8, this is argons, or these are all group 8s. So answer is that. So the answer is C. Consider the following processes: sublimation, condensation, filtration. Which combination of above process is a physical change? All of them are physical changes. There is no chemical change here. There is no new substances formed. This is just change of the state or shape or the texture. So that's it. So I'm looking for 1, 2, 3. So the answer is D. So you get the marks there. They're saying that which one of the following groups of elements show the correct trend of the atomic radius of elements? So when you say atomic radius, as you are moving from across the group, the atomic radius keep on reducing. Why? Because you're adding electrons on the same shell. Therefore, the attraction increases and then the size decreases. And as I explained yesterday, that as you're going down the group, the atomic radius increases because you're adding the number of shells. So now let's look at this. This one, no. Bromine is, no, iodine is greater than, bromine is greater than chlorine. Yes, here. So they started from this side. No. This is not, they started from the group 7 going upwards. So if you check the periodic table, you'll find out that, let me show you. I think I should just show you what I'm trying to say. They are looking for this, you see, here. Iodine, bromine, chlorine, fluorine. That's what they are looking for. So anyway, I think you understand where I got the answer. So the answer is that. Then they are saying that consider the unbalanced equation. Now here, you cannot fail to get the answer correct here. At least make sure that this side is balancing with this side. That's all. And they gave you the figures here. So when you balance, you'll see that this is 4, this is 1. Then if I put a 4 there, 4, 4. Then here is 2. So it means that here is 2, here is 2, here is what? Is, check, 4 times 3 is, so I put a 6 here. You see? So it is 1, 6, 4. So the answer is A. Then we go to the molecular mass of carbon dioxide is, you calculate. Carbon is 12, oxygen is 16 times 2, which is 32. This is plus. Then you get 4, 4. So the answer becomes this. You see, it's simple. They brought this one so that you guys, you can pass. Ne? Anyway, let's go to the next question. They're asking you what is a pure substance. When you talk about these definitions of a pure substance, what comes into your mind? So what is a pure substance? A pure substance is that substance which is formed from constant composition, and the properties of this is the same or is constant throughout. Meaning that the matter which make up of this substance is the same. The property is the same, and then they are constant throughout. Meaning that when you look at maybe oxygen, it becomes a pure substance. Meaning that there is no other things which involved in oxygen. Yes. So it becomes a what? A pure substance. So meaning that it is constant throughout. Then they are saying that that's the definition. So it depends on what your teacher has defined. Then they are saying that complete the table below. Write down only the question number, this, and answer in your booklet. Anyway, all right. Gold. What is gold? They want to know whether is the element, compound. Gold, AU, is an element. Yeah, so it's an element. It's not made up of with other things to make a compound. No. Resin is made up of the same. So it's a pure substance. Actually, is an example of a pure substance. So it is made up of the same atoms. That is gold. It's not a mixture. So they're saying that brass is a mixture. Yes, brass is a mixture. Actually, this is a mixture. Oh, they said it here. It's made up of zinc and actually copper. Yes, so that's what you call the brass. Next time they will bring bronze, so you have to know those things. Explain why pots and pans are made up of metals. Yes, they are made up of metals so that they can conduct electricity, can conduct heat. In this case, they are conducting heat. They are good. They are made up of metals which are good conductors, so they can conduct heat. But the handles are made up of woods or plastics, so that these are bad conductors, or they are good insulators. Yes, so that you don't burn when you're holding these saucepans or pots. Yes. They're saying grade 10 learners performed an experiment to investigate the effect of increasing temperature on a solid substance over a period of time. And they are saying that the experimental results are shown in the figure shown in the heating curve. This is a heating curve. Yesterday, I showed you the differences, the different curves, the cooling curve and the heating curve. And I said that we're going to bring one. Anyway, we brought the heating curve. They're saying that what is the independent variable? Obviously, guys, what is on the y-axis is dependent on what is on x-axis. Because if this x-axis is not there, this one cannot stand. Check. So independent, dependent, and this is independent. Yes. As I told you that x-I-D, x-y. Independent on x-axis, dependent on y-axis. Simple. You come here and then check. Yeah. So you can modify it here by this, but still it gives you the same thing. So they're saying that define the boiling point. Boiling point, when we talk about boiling point, is the point when the vapor pressure of this liquid is equal to the vapor pressure of the liquid is equal to the atmospheric pressure, or the pressure of the gas above it, whatever definition you are using, but the atmospheric pressure must be equal to the vapor pressure which is being produced by this liquid. Then we go to the next question. They're saying that the temperature remains constant between this and this. The temperature remains constant. Why does the temperature remain constant? Between 20, what is 20? 20 and 25. 20 and 25, okay? They're saying that explain this phenomenon in terms of kinetic molecular theory. So basically, between 20 to 25, what happens? But it is the boiling point. 20, and 25. Here, we are expecting boiling. This, meaning that it is in the phase. That's the boiling point. Yes, hopefully they're going to give you a mark, you mentioning boiling point. So the temperature of the liquid, yeah, is going to remain the same. It's going to remain the same. So, and this, because it is remaining the same, it's supposed to accumulate. But does not mean that because the temperature is remaining the same, what happens? The speed at which these particles increasing, they start to increase. So when they increase, it means that the average kinetic energy of the molecule will start to increase. You understand? Once it starts to increase, now you undergo this gaseous form, gaseous state. You understand? Yes. So when they increase too much now, but the temperature will remain the same, but the speed at which these particles are moving will start to increase. And once they start to increase, they start to, the bonds, they break, they bounce. When they bounce, boom, 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 boom. And then after that, yeah, they start to escape. And then now you see the boiling will start to increase, but the temperature remains the same. So let's go to question 3. They're saying that in 1932, that's the year when I was born. When were you born? I was born in 1932. How old am I? Anyway, now someone is telling me that, you are lying. Thank you for being for being my mother and being my father. Actually, you are saying that I was not born in 1932. Anyway, that's not the business for today. It was discovered that atoms of the same element can occur in different forms. We call them isotopes. Different forms of certain element X and their percentage abundance in the sample are shown below. Okay, they are shown below. Anyway, you have this and you have this. We calculated this yesterday. I think you're able to get the answer. Calculate the relative define what is isotope. Atoms of the same element with the same number of protons, but different number of neutrons. Atoms of the same, not elements of the same atoms. No. Atoms of the same element with the same number of protons but different number of neutrons. Simple. Then they're saying calculate the relative atomic mass of X. So here I showed you, I'm not going to calculate, but I'm going to show you how the answer you are supposed to do on this. It means that you have to add the mass here and you have to add the mass here. So 50% means 50 out of 100 times the mass here, which is 106,9 plus 50 out of 100 times the mass, which is 109,1. So when you add these two, you have to be able to get the atomic mass of that. And then when you calculate, this one will give you around 53.4, and then also this one will give you something like that, and then the total is 0.8. Yes, sometimes they can ask you identify this element. Oh, they have said this. So identify element X. So you go to the periodic table and look for what has atomic mass, not atomic number, not number of protons, atomic mass as this. So when you go there, yes, to the periodic table, you will find that the answer is silver. Let's go to the next question. I explained this yesterday also. I think it was clear. If it was not clear, let's go through it and then we see if you obtained it. Sodium. This is, guys, this is an atom, while this is an ion. I say that if it is an ion, this charge, it means that if it is positive, it means that the number of electrons are short by 2. If it is negatively charged, the number of electrons are more than 2. But how do I know the number of electrons in an atom, not an ion? Look at the number of protons, because the number of protons and number of electrons are the same in atoms. So atomic number is the number of protons, but here you have atomic mass number is 23. Do you have the neutron number? Atomic number here is given already, which is 11. So the answer is there. Just copy and paste. Number of neutrons. How can I get the number of neutrons? Number of neutrons, remember that atomic mass is equal to number of protons plus number of neutrons. So it means that sometimes use Z. So it's the same thing. So it means that I'm going to say is 11. Atomic mass is 23 minus 11. It must be giving me number of neutrons. So when you subtract here, what do you get? I think you get 12. What about here? Number of electrons, the same as number of protons. Why? Because this is an atom, it's not an ion. So I will write 11 there. Then they're saying that here is fine. Number of neutrons, this minus this, I will get this, which is 20. What about number of electrons? Remember, number of electrons are the same as number of protons in an atom, but this one is an ion. It means that it's going to be short by 2 minus 2. So the answer here is going to be supposed to be 20, but because it has lost 2 electrons, so it's going to be 18. Think I'm clear there. Then we got to draw the box diagram of the following substances. When you talk about this one is also simple, very simple. How simple? Let's see how simple is it. All right, So you have to know how to write the designs. 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, 5s, 5p, 5d, it's fine like that, 6s, 6p, whatever, 7s, okay, like that. So I think we have got it. So once we get that, now you go to phosphorus. You go to the periodic table and find out what is phosphorus. Phosphorus is 15. What about potassium? Potassium is, what is potassium? Potassium is 19, but they said potassium ion, meaning that it has lost 1 electron, meaning that it is 18. So meaning that you're supposed to draw the boxes showing this. So for this one, you're gonna draw, you start with this 1s, box, 2 spin, 2s, 2s, this is 1s, 2s, still spin, and then they're saying 2p, this is 2p, 2p, spin. Don't forget that this is 2 to go to p plus 4. I showed you yesterday, so meaning that this 2, so it's gonna be 6. To go to d is gonna be plus 4, 6 plus 4, so it means this is gonna be 10. To go to f plus 4 again, you keep on adding 4, 4, 4, 4. So it's gonna be 14 here for f. Anyway, so now because this is p, p is gonna be 3 of them. Then I go to 3, 3s, 3s. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then I go to p. P is gonna be 12, 13, 14, 15, like that. So that's what is supposed to be written. Simple. So this is for phosphorus. What about for this? It means that for this one, I'm gonna add is gonna be the same 1, 2, 3. Don't forget the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. It's gonna be 18. It's gonna be full like that. That is for potassium ion. Do you understand? Yes. So I think this is really simple. It was simple now. Yeah, let's go to ionization energy. I explained this yesterday. I hope you get it. You got it right. Define ionization energy. When you talk about what is ionization energy, is the minimum amount of energy required to remove 1 mole of electron from a gaseous atom or ion or molecule. Yeah. To ionize, it means that you are removing 1 mole of electron from so that minimum energy you require to remove that mole of electron. Sometimes at this level, sometimes we don't talk about mole of electron, just that minimum of energy required to remove mole of electron, to remove electron from a gaseous atom, yes, or ion or molecule. Still is fine. Yeah, they will give you a tick. So they're saying state the general formula, general trend in ionization energy from left to right across the period in the table, periodic table. From left, I said left to right. Don't forget that from left you have big, like that. So it means that the ionization, because the electrons are coming closer to the nucleus, it means that there is high attraction. So you require a lot of energy to remove one electron from here than here, because this one is too far. Yes. So so from left to right, the ionization energy increases as you move from left to right. Yes. So they're saying explain the drop in ionization energy from neon to sodium. Let's go to neon. Neon is here, and then sodium. If you look at electronic configuration of neon, yes, you find out that its last orbital is full, while here the last orbital is having 1 electron. So it's easy to remove this 1 electron than to remove it from the full one. You understand? This is already stable, and this one is unstable, is able to release 1 electron. That's why here the ionization energy is higher than the ionization energy here. Why? Because this one has 1 electron, which can easily give out, while this one is already stable. Is a noble gas. Is a king. These are kings and queens in elements. All elements react so that they can become like the noble gases, the group 8 elements, so that they are stable enough. Let's go to the next question. They're saying that ammonia is in manufacture using industrial process known as Haber process. It reacts with the substance nitric acid to form inorganic fertilizer ammonium nitrate. Write down the chemical formula of ammonium nitrate. I told you that this is ammonium, and then nitrate is like that. I explained this yesterday, and then when you cross this they cancel. Therefore, ammonium nitrate becomes like that. So that's the symbol. Then they are saying that write down the name of this. This is nitric acid. Nitric acid. I said it yesterday also. Name the type of bond formed between atoms. Guys, subscribe to Thunder Educ so that you don't miss out. We don't only talk about sciences, we also talk about other subjects. Tell your friend so that all of you get distinctions. Anyway, let's go to the next question. They're saying that name the type of bond formed between atoms in ammonia and ammonia molecule. Give a reason for your answer. When you talk about ammonia molecule, which type of bond forms? The type of bond formed between atoms. They're saying atoms of ammonia, not molecules of ammonia, meaning that they are looking at the intra-specific, molecular forces of attraction, the molecules, the bonds that they are looking for. So it's covalent bonds. Yes. Give a reason. Because of the sharing of electrons. So here, check here, is sharing of electrons. Draw the Lewis dot diagram for ammonia molecule. Ammonia molecule, we say that ammonia molecule looks like this. Ammonia. Yeah, we said the shape, they didn't ask it for the shape, but we said that this shape is, we said, how do we call this shape? We said it's called trigonal pyramidal. Yes, it forms a triangle, and then a pyramid on top. Trigonal and then pyramidal. Then they're saying that, so basically that is the shape. Yeah, so it's supposed to be like that. They're saying that the Lewis diagram of magnesium oxide. Magnesium oxide. Don't forget that this is a metal and this is a non-metal. So it means that magnesium is gonna transfer the electron to that. So it means that magnesium is supposed to be magnesium with the 2 electrons, and then this one is 1, 2, 3, 4, 5, 6. So these 2 are going to come and join here. So basically, when they join here, it's going to have that and that. But now this one is going to become positively charged, and then this one is going to become negatively charged. This is a positive 2, meaning that now these 2, they have gone. So basically the structure, they looks like that. However, you have other way how you can express it, so depending on what your teacher taught you. Then they're saying the explain the difference between chemical change and the physical change. Here there is formation of new substance. Here there is no formation of new substance. There is only change in the state. It can be state, it can be texture, it can be state, texture, or phase. Yes, so basically that's what is involved. But here there is formation of, basically this one in most cases, new substances are formed. Classify the following processes, either physical or chemical. This one is a chemical, rusting. Yes, iron 3 hydrate. Yes. Then they are saying here, this one, salt dissolved in water. We can separate it again, and then it means that no new substance is formed. This is physical. So this is chemical. Sorry, this is chemical. This is physical. Nitrogen gas separated from air. This is physical. Then they are saying that why does they're saying that the balanced equation for sodium hydrogen carbonate, sulfuric acid, sodium sulfate, water, and carbon dioxide. Write the balanced equation. When you balance, this is 2. It means that I put a 2 here, and then if I put a 2 there, it means that these hydrogens are 2 plus this. It gives me 4. But here I have 2. So if I put a 2 there, it becomes 4. And then carbon here, there are 2, while carbon here is 2, is 1. So I put a 2 here, I put a 2 here, and I think that's why they gave the 3 mark. This is a solid, this is aqueous, this is a solid, this is a liquid, and this is a gas or aqueous. All right, they're saying that why does the law of conservation of matter does not apply when gas present as compound in a chemical reaction in open system? Because the gas escapes, and then the mass, the resultant mass, is not going to be the same. Here there is escape of gas. Yes. And then they're saying that prove the law of conservation of mass for the following chemical reaction. So let's see that the mass this side and the mass this side is the same. Nitrogen is 14, and then hydrogen is 1 times 1 times, there are 2 of them, times 3, and nitrogen here is 2 of them, so it's 28 plus 6, which gives me 34. Yes. So what about this side? I have nitrogen, which is 2, is 14 times 2, which is 28, and then hydrogen here, hydrogen is 1 times 3, but 2 moles times 2, which gives me 6 still, and gives me 34. So it's 34 is 34. So the answer is correct. Then lastly, but not the least, is it the last? Yes. Calculate the relative formula mass of the following substances. You have to check on the periodic table. I will not check the periodic table because this periodic table is in the head. All right, nitrogen, all these things you have to check them from the periodic table. Yeah. So nitrogen is 14, hydrogen plus, but how many nitrogen do I have? There are 2 of them, times 2, and then hydrogen plus, hydrogen is 1 times 4 times 2, isn't it? Yes. Then plus sulfur is 32. Yes, it's only 1. And then oxygen plus oxygen, which is 16 times 4 times 4. So you calculate, the answer you get will be there for this. And then lead PB is lead or lead, whatever this. Yeah, so lead is PB is 207, 208, 207. Yeah, it's isotopes. There's one for 207, 206, and 208, but this is the from the periodic table. 207 plus nitrogen, which is 14 times 2, because sorry, why it's times 2 because of this, so times 2 plus oxygen, which is 16 times 3 times 3. So the answer you get here, yeah, to be the answer here, I think you'll get around 331, and then here you'll get around 12132. If my addition is not right, so just have to get the correct addition. I think that's the paper. Yeah, the paper was very easy. You see, we have done this paper in less than 30 minutes. The paper was easy. And those people who watched our predictions, I think you got a distinction. Thank you very much.